All right, solving 2x2 systems graphically and algebraically. Let's go. First things first, know that a system of equations is when you have a set of equations with the same unknown variables. Now, if you have two unknowns like an x and a y, you need two equations. If you have three unknowns like an x, y, z, you're going to need three equations. So however many unknowns you have is how many equations you'll have. A solution set is the ordered pair that satisfies both of the equations, making them a true statement. Okay, so let's talk about this right here. So there's some possible solutions when we talk about a graph. First is that, see these two lines here where they cross? Right here, that would be one solution, x comma y. So a totally normal one, straightforward, where two lines cross, x comma y. Then you could also have this mishap. So you could graph a line, and then when you go to graph another line, it ends up being right on top of that same line. Okay, so I literally call this same line. So that means it has infinitely many solutions, and there's a certain way we'll write this today when we run across one of those problems. And this is just graphically. We're going to talk about what happens when you solve it algebraically, how you know you have infinite many solutions. And then the last thing that we're going to talk about today is no solution. That's what happens when you have two parallel lines. I do have underneath, when solving, the variables will drop out and you'll get a true statement for infinite many. And when solving, variables drop out and it's a false statement for no solution. And we'll talk more about that when we get to those problems. Remember, you can go as fast or as slow as you want on the videos. You can pause me, you can go back, you can rewatch. This is totally all about you and whatever pace you're most comfortable with. So there's three methods of solving you're supposed to already know, which is substitution, elimination, and solving by graphing. So first let's talk about substitution. I have the steps on the side, but I'm just going to talk through these. The easiest variable to get alone is always going to be the variable that has a 1 as a coefficient. And here's why. So if I subtract 2y from each side, I get 2 minus 2y. Now we have x alone. And what you want to do is you want to take what x equals and you want to put it in where the x is. So what I'm going to do is bring everything else down from that line. But in place of that x, I'm going to put in the 2 minus 2y. Okay? And then from there, we want to just go ahead and solve. So I'm going to distribute my 5 and get 10 minus 10y. And then I'm just going to bring everything else down. And then I'll start collecting like terms and solving. So here we have 10 minus 13y equals negative 29. I'm going to subtract 10 from both sides. So negative 13y equals negative 39. And then I'm going to divide by negative 13. So y gives me 3. Remember, if I'm going fast, pause me, go back, rewatch, do whatever you need to do to keep up. I highly recommend watching the video the first time and writing nothing, and then going back the second time and writing everything down. You really will have it down if you do that. Anyway, so now that we know y is 3, we can go back up here and we can substitute it in. So x equals 2 minus 2 times 3. So this would be x equals 2 minus 6. So x will be negative 4 then. And last but not least, you're telling me where two lines cross. Even though we're doing this algebraically with substitution, you want to tell me where the two lines cross. Well, that's going to be at an ordered point. So 4, 3. Make sure you're always alphabetical with your point. And there we go. That's substitution. The next one we're going to review is elimination. You may have heard it called linear combinations before. The first thing you look for is, does anything cancel if I add down? Like 3a plus 6a, well, that's not 0, and I want something to be 0. And then the 4b plus 8b, again, that's not 0. So you're going to have to multiply either one equation or both equations by something to get a variable to cancel out. You want them to have opposite coefficients. Like if you have a 5, you want the other one to say negative 5. You know what I'm saying? So looking at this, I'm just going to pick on the a's. And down here we have 6a. So I know if I multiply the top here by a negative 2, that'll give me negative 6 and I'll be able to cancel them out. Make sure that you keep everything really nice and neat and organized when you do these, because it's easy to get lost otherwise, for me and for you. So if I multiply everything including the 10, which is what people forget, by negative 2, this is what I get. And then I'm just going to line that other equation I have right up underneath it. Here we go. Then you want to add down. Now, something weird happens on this one, and I picked it for a reason. So over here we get 0, but then over here we also get 0. So notice that the variables dropped out, and 0 does equal 0. That's a true equation. Here's where I talked about those special cases right here. So the variables dropped out, but it's a true equation, which means it's infinitely many solutions. So this is true. And yes, it's infinitely. I'm going to spell it wrong. I think there's an E in there, right? Yes. Infinitely many solutions. Okay, here's the deal though. I want you to be more specific. What does this actually mean? It means that if we plug any value in for A, we'll get the same value for B in both equations. If I plug in a value for B, we'll get the same value for A in both equations. So what I like to do is just say it's all points on the same line as. Now you could use either of these lines, right? Because think about it. When it's infinitely many solutions, this is the same line. It's a line on top of a line. They're touching everywhere forever and ever, which is why they have infinitely many solutions. So you can say it's all points on the same line as 3a plus 4b equals 10, or 6a plus 8b equals 20. It does not matter at all. I like to go with the first one because that's just me. But there you go. Okay? So they touch everywhere on this line. All right, so let's go down here. Solve using a method of your choice. Now, I'll be real honest. Unless there is a variable here that has a coefficient of 1, I don't use substitution. And quite honestly, I like elimination better than substitution anyway. So looking at this, I see this is 6x and this is 2x. So if I multiply this by a -3, we should be in business. So -6x minus 9y equals -45. I'm going to bring the other equation down underneath it, just like this. Boom. Add down, and again, this is another weird thing. I get 0 here equals -35. So again, my variables are dropping, but I'm getting a false statement at this point, all right? False statement. So if we go back and think about the special cases, there's the infinitely many solutions and the no solution. And the no solution is when solving, variables drop out, and it's a false statement. Okay, so these must be parallel lines. So false, no solution. So these two lines, if we were to graph them, are parallel lines. So they have no solution because they never touch. Last but not least, we've got solve the following systems by graphing on your calc, sketch a graph, and label your point of intersection, round your answer to the nearest thousandth. Notice number 4. We do have 2 equations and 2 unknowns, but they gave us 3 equations, and that's fine. We're going to deal with this. They want us to graph, so if we're putting it into y equals, we're going to have to get the y alone. So on this one, I will have -y equals -3x plus 5 when I subtract 3x from both sides. And then I'm going to divide everything by -1. So y equals positive 3x minus 5, just like that. So then I'm going to star this, because that one I want to pop into the calculator. Over here, I would subtract 2x from both sides. So 3y equals -2x plus 7. Okay, then divide by 3, so y equals -2 thirds x plus 7 thirds. And that's the second one I'm going to put in the calculator. And then this guy over here, I'm going to subtract x from both sides. So -4y, -x plus 9. And then I'm going to go ahead and divide by a -4. So y equals, be careful here, this is a 1/4 x, and then minus 9/4. So these are the 3 equations I'm going to put into the calculator. Let me grab that. I'm going to hit y equals. Here we go. And I'm going to type in 3x minus 5. Move this down. I got -2 thirds. I tend to put fractions in parentheses. That's just my prerogative. It'll never hurt. Let's put it that way. Okay? Could only help. So I've got that, and then I've got my 1/4 x minus 9/4. Oops. Just like that. Double check that you actually wrote them in correctly. So -2 thirds x. It looks like it's good. So we're going to go ahead and graph it. Let's see what this looks like. Okay, so we do have 3 lines here that are in 3 different colors on our screen. So let's go ahead and give a little sketch of this. So it looks like to me, we've got the first one that comes down like this. I'm just going to bold mine. And then we have the blue one that comes down like this, just a little bit up in the first quadrant. It touches there. Something like this. Okay, and then we have the black one that kind of cascades down here more. It touches these two in the fourth quadrant. So I guess kind of like this. Okay, now here's the deal. The solution is where these three lines cross. So at what point do all three of these lines cross? Look at it. Nowhere. All three of those lines do not touch each other anywhere. They all three have to cross at the same spot for there to be a solution. So in this case, this is no solution. Automatically you can look at it and you can see it's no solution. Notice they're not parallel. We talked about how no solution is parallel lines. Well, that's true, but in this case we have three lines we're working with. So it's not going to be about parallel lines, it's where do all three of those cross each other. And they have to do it in the same spot, and they don't. So that's why it's no solution. So if we go over here on this one, we are going to get y alone here. So this is negative 3y equals negative 2x plus 1. We're going to divide by negative 3. So y equals 2/3 x minus 1/3. Be real careful with your positives and negatives. So there's the first equation we put in the calculator. And then here we have 5y equals negative 4x plus 3. And we're going to go ahead and divide everything by 5. So y equals negative 4/5 x plus 3/5. And that's the second one we're going to put in the calculator. So let me scooch this over here so I can pull up the calculator. And then y equals, I'm going to type in 2/3 x minus 1/3. Okay, so 2/3 x minus 1/3. Let's clear this, let's clear that one. And then here we're going to have negative 4/5 x plus 3/5. And then we're going to graph it. See what it looks like. Oh my, so it looks like they cross each other somewhere in the first quadrant, maybe really close to the x-axis. Okay, so there's that. Schnikes. So if this is the first one, the second one kind of crosses it. I feel like something like that. Okay, so something like that. Now, they do cross somehow, so it does say on your paper to write down, or to do trace, let's see here. They wanted to do second, trace 5, enter, enter, enter. Okay, so let's do that. So on the calculator, second, trace 5, enter, enter, enter. And they want you to round to the thousandths. So this would be 0.36, or 0.636. So right here's where they cross. 0.636, comma, 0.091. 0.091. So this is where those two lines cross. All right, that's it for today. You'll be expected to know it tomorrow because it is pure review. If you need to rewatch it, rewatch it. And until next time, goodbye.